Today is the first lecture regarding the electrical engineering. I will give the introduction about the electrical sources. So in today's lecture, I will discuss the following topics like definition of the electrical source, type of the electrical sources. These are basically two type of the sources we are using in the as electrical sources. One is the voltage source, another is the current source. So both
Yes, sir.
voltage source and current source again divided into category, the ideal sources and practical sources. And in the last of the lecture, we'll discuss about the independent and dependent voltage and current sources. So we'll go to the electrical sources. So we have seen so many electrical sources in our daily life. So all the electrical device or any device having a active or passive components that can convert any type of the energy means mechanical, chemical, thermal or some other form of the energy into the electrical energy is called electrical source. Or you can say electrical source is an active network element that will generate the electrical energy. So it just a kind of the transducer. You know the transducer functionality of the transducer that will perform the conversion of the one type of the energy to the another type of the energy. So this is
Okay,
a
sir.
special type of the transducer that will convert any type or any other form of the energy into the electrical energy. We know that we are having two type of the electrical sources. One is the voltage source, another is the current source. So again, you can see the chart as shown in the slide that again these voltage source and current source are characterized in two category, ideal voltage source and practical voltage source. Similarly for current, ideal current source and practical current source. So basically what is the voltage source? Voltage source will force the function of the EMF, electromotive force, whereas the current source has a functionality of forcing the function of the current. So in the diagram, it is shown very clearly that how we are characterizing the different type of the sources in the form of the ideal and practical means. So basically voltage source is a two-terminal device that will provide constant voltage at any instant of time. At any instant of time or complete duration of the operation that will provide a constant voltage. That is, that constant voltage is independent of the current drawn by the circuit. If you see the right hand side diagram, you can find out the characteristic of the ideal voltage source. That VAB is the terminal voltage. Here we are having two voltages. One is the voltage source and second is the terminal voltage. So voltage source is connected across any terminal and it is not having any drop for all the time of the operation or for all the value of the current. It will provide a ideal or constant voltage. So on the left hand side, I have shown the diagram, simple diagram for the voltage sources. So these are called ideal voltage source and internal resistance of the ideal voltage sources are zero. So most of the time we use this battery sign in electrical engineering means we generally use a battery sign because we are using DC voltages. And this circular sign can also be used whenever we are using alternating type sources. DC source also we can use this circular, but most of the time we use battery sign. So one of the important characteristic of the ideal voltage source is that it is having zero internal resistance. So whenever we have to disable the voltage source in the circuit, we always replace this voltage source with their internal resistance. So sometime in some of the circuitry, internal resistance can also be given. So in that case, whenever you want to disable the voltage source, we always replace the voltage source with their internal resistance. But in case of the ideal voltage source, we always replace the voltage source with the short circuit because internal resistance is zero. But in case of the current source, we always replace the current source with an open circuit because the internal resistance of the current source is infinite. Practical voltage source are the electrical devices that is having some amount of the internal resistance. And due to this internal resistance, some voltage drop will take place in the circuit and terminal voltage will be reduced. That condition can be understood by this formula I have written here. VAB is the terminal voltage, V is the voltage of the voltage source, I is the current drawn by the circuit, and R is the internal resistance of the voltage source. So VAB is the terminal voltage that will be reduced by some extent that will be given by the product of the internal resistance and the current drawn by the circuit. So you can see this equation that VAB is equal to V minus IR. So because of this practical nature of the voltage source, it will not provide the same value of the voltage at the terminal. Some voltage drop will be there. So for modeling purpose of this drop, we have to analyze one internal resistance that will be connected in series with the voltage source. As we can divide the voltages in the series circuit, so we have to connect a model value of the small resistance in series with the voltage source. So you can see the characteristic also in the diagram that with the time this terminal voltage VAB is going to be reduced. Means after some time this we have some loss of the voltage in the terminal voltage. That loss is equivalent to the I into R. I is the current drawn by the circuit and R is the internal resistance of the voltage source. If we want to take one condition that if R will become 0, so IR product term will become 0, so VAB will be equal to V. So in that case, what will happen when this internal resistance of the practical voltage source becomes 0, this practical voltage source will be converted to or equivalent to the ideal voltage source, because VAB will be equal to V. Terminal voltage will be equal to supplied voltage. There is no loss, no reduction in the terminal voltage. That's why this internal resistance of the practical voltage source is always taken as small as much possible, so that behavior of this practical voltage source will be more closer to the ideal source. So current source, you can see the symbol diagram. Two diagrams are there. One is the rectangle symbol diagram is there. One is a circular diagram is there. You can see in both the shape we have shown a arrow. Arrow will give the indication about the direction of flow of the current. So ideal current source is also a two-terminal circuit element that supplies the constant or same current all the time of the operation, and this constant current is independent of the voltage of the source terminal. Just like the voltage source will provide the constant voltage that is irrespective of the current drawn by the circuit. Same here, ideal current source will provide the constant current throughout the time of the operation, and that is independent of the voltage source. And one of the important property of the current source is that it is having infinite internal resistance. Voltage source is having zero internal resistance, and current source is having infinite internal resistance. And we will see why it is taken as an infinite value. So this slide discusses about the practical current source. Similar to the voltage source, this practical current source is also modeled with a internal resistance connected in parallel with the current source. Okay, as you can see the characteristic of the current source, after some time this terminal current is going to decrease. You can see the diagram here. We are having the highest value of the current, and after some time, as time is passing, value of the terminal current is going to decrease. So anyhow, we have to model this loss of the current. So all this modeling is done in terms of the internal resistance. In case of the current source, this internal resistance is connected in parallel with the current source, because current is divided in parallel circuit. So you can analyze the condition. Suppose at this A, IT is the terminal current, I is the supplied current. So IT will be equal to I minus V upon R, where V is the terminal voltage across the EB. So IT will be equal to I minus V upon R. So if R will become infinite, so V upon R term will become 0. In that case, this IT will be equal to I. So this practical current source will be equivalent to the ideal current source if resistance, internal resistance of the practical current source is infinite or high as much as possible. Remember, in the case of the voltage source, internal resistance should be smaller as much possible, equivalent to 0. But in practical current source, it must be high, maybe equivalent to the infinite, very high value. So in case of the practical current source, we are having the internal resistance that is connected in parallel with the current source. Both circuit, voltage source connected with serial resistance and current source with parallel resistance, both are equivalent to each other. We'll see later. So now coming to the independent and dependent voltage and current source. As you can see in the chart shown in the slide, that energy source is divided in two type of the sources. One is the direct source, second is the alternating source. And in the electrical engineering circuitry, we generally use direct sources. That's why further classification is given only for the direct source. So direct source is also having two type: independent voltage and current source, dependent current and voltage source. So just now we have seen ideal and practical current and voltage source, that are the independent voltage and current source. Some other category of the voltage and current source is also there, that is whose value is not fixed. Okay, that is called dependent voltage and current source. So again, this dependent voltage and current source is divided in 4 categories. Okay, first one is the VS, voltage controlled voltage source. If a voltage source whose value is controlled by the another voltage either in the input side or in the output side. Similarly, voltage controlled current source, a current source element whose value is controlled by the some other voltage in the circuit. Current controlled voltage source, a value of the voltage source is controlled by the current flowing through any particular element or in the circuit. And last one is a current control current source, the circuit of the current source whose value is controlled by the another current available in the either in the input side or output side. So independent source are the sources those are not dependent on any other quantity in the circuit. These are the two terminal devices that provide a constant value, means voltage source will provide the constant voltage and current source will provide the constant current value irrespective of the all circuit condition. And the value of the current and voltage provided by the voltage and current source is not changed by any variation in the connected network. So these are the independent voltage and current source. That's why it is called independent voltage or independent current source. So in this case, value of the voltage and current is always fixed. It is not adjustable. But these independent voltage and current source are having the fixed value that cannot be adjustable. Our main concern is now about the dependent voltage and current source. So dependent voltage and current sources are the device whose values are not fixed, and that value is dependent on any other quantity in the circuit, either any other voltage in the circuit, either in the input side or output side. Similarly for the current source also, whose current value is depending on the current or voltage available either in the input side or output side. Okay, so these type of the sources are called dependent or controlled source, and these are the 4 terminal devices. This is the big difference between the independent and dependent source. Independent voltage and current source are the 2 terminal devices, but this dependent and controlled sources are 4 terminal devices. These are the dependent and current controlled source, means whose value either voltage or current have some changes according to the change in the connected circuit. Yes, because these values are dependent on any other connected network value, either voltage across any resistor, current flowing through any component. Yes. Means these are the dependent sources. Okay. And one of the most important thing is that the dependent sources are represented by a diamond shape. If it is a voltage, so plus minus sign will be there. If current source is there, then arrow will be there. So we are having 4 type of the sources. Basically, we are having 2 sources, voltage source and current source. But in category of the dependent sources, we are having 4 type of the sources. One is the voltage controlled voltage source, means whose input voltage is depending on the voltage provided by the some other component current voltage value or some other section voltage value. Next is voltage controlled current source, input current source whose value is dependent on the voltage provided in the same side circuitry or other side circuitry. And current control voltage source, similarly voltage source whose value is depending on the some current element. And last is the current control current source, means current source whose value is depending on the current element either in the input side or output side. So these dependent sources are having 2 sections, input side and output side. That's why these dependent sources are having 4 terminal, not the 2 terminal. Independent sources are having 2 terminal, but dependent sources are having 4 terminal. So we can see the diagram for the voltage control voltage source, that is dependent voltage source whose value is controlled by the voltage available in the either input side or output side. So here you can see the diagram, that diamond shape is given plus minus whose value is given by the VAB. But try to understand this functionality. Here VAB is the controlled voltage source whose value is controlled by the another voltage in the circuit, that is VCD. So VAB is proportional to the VCD. If there is any change in the voltage across this resistor or change in the voltage in the VCD, according to the, there will be a equivalent change in the VAB. Source terminal VAB is dependent on the voltage across the terminal VCD. So VAB is proportional to VCD. So if we remove this proportionality sign, there will be a constant, and this equation will become VAB equal to KVCD, where K is the constant. This K is a unitless quantity. because K is equal to VAB upon VCD. Both are the voltages. K is a unitless quantity, right? Voltage divided by voltage. So it's a constant.
Yes.
So now moving to the another type of the voltage source or current source. Yes, that is voltage controlled current source. So here you can see one diamond shaped current source is there whose value is depending on the VCD. So from the equation you can see that IAB is proportional to the VCD, where VCD is the terminal voltage across the CD terminal. So if we remove this proportionality sign, we'll find out that IAB is equal to neta VCD. If we want to know the unit of the neta, that is IAB divided by VCD, current divided by voltage. So what is this value? Current divided by voltage, conductance. So unit of this proportionality sign in this voltage controlled current source is Simon or ohm inverse. Now coming to the current controlled voltage source. So here again we are having the diamond shape in the input side. This VAB is depending on the current available across this resistance, that is equal to ICD, shown in the figure. So if we write down the things, that VAB is proportional to ICD. If we remove this proportionality sign, this VAB will be equal to RICD, where R is the proportionality constant. We want to calculate the unit of the R, that will be given by VAB upon ICD, voltage upon current, that is equivalent to ohms. So if there is any change in the current across this resistance, or there is any change in the current value of ICD, correspondingly we will get the change in the VAB. So this is the current controlled voltage source whose value is depending on the current component available either in the input side or output side. Here we have taken the component, one resistive component in the output side. So here you can see in the input side we are having a diamond shape with a arrow sign. We can understand very easily that it's a current source, and it's a diamond shape. It means it's a controlled current source. Okay, with the equation given along with this diamond source, we can find out whether this value is depending on the voltage or current. So equation will be given that IEB proportional to ICD, means this current source is depending on the other current source, other current value, either across the terminal or across any component. So if we remove this proportionality sign, we will get IAB is equal to beta ICD. If you want to know the unit of the beta, that will be given by simply division of the IAB divided by ICD. Both are ampere, so beta will be a unitless quantity. So this is the basic thing regarding the electrical sources.